So here's the first problem where it's not just purely conceptual. This is going to involve some calculation. And one of the first things you'll notice is the absence of a coordinate plane. And that's because the transformations we'll be doing, it's safest, it's quickest actually, to do them following the algorithm, following the rule. But you do need to know the concept, okay? So what is the image of the point? And I'm just going to call this point arbitrarily, I'm going to call it A. So 2 comma negative 3. Under a clockwise rotation. Now since we're educated, 90 degrees, we know that's a negative 90 degree rotation of A. And that should be my subscript, negative 90 degree rotation of A. But, you know, this is the Regents exam, they kind of got to spell it out for you, and they tell us, well, when you rotate clockwise, that's a negative rotation, okay? Well, on your coordinate plane, all right, if your point is in quadrant 1, right, it's right here, negative 90 means go clockwise, right? Negative 90 means go clockwise. So each quadrant's 90 degrees, so when you go negative 90, you're going to wind up in quadrant 4. If you don't remember the rule for a rotation of negative 90, that's okay. We're just going to go the other way. What's the positive way? How many rotations is that to get into quadrant 4? Going counterclockwise, the positive direction. Well, that's a 90, another 90 for a total of 180, and then a third 90 for a total of 270. So a rotation of 270 is the same as a rotation of negative 90. They're the same. So I'm going to follow this rule, all right? I'm going to negate my x and then switch my terms. All right, so a prime, okay? Well, oops, sorry about that. A prime, I'm negating my x and then switching. Well, my x here is 2, so it's going to be negative 2, and that's got to go to the back, and then I'm going to take this negative 3, I'm going to put it to the front. All right, and there is my point, A prime. That's the image of A under the rotation of negative 90 degrees about the origin. Thanks.